does rolls or mean value apply? Which one applies if either? So for stipulations for both rolls and mean, the first stipulation, is it continuous? So is it continuous? Well, there is a discontinuity. When 3 minus x equals 0 would be a discontinuity. When you solve that, when you solve this one, you end up with x equals, you minus the 3 over, you get negative x equals negative 3, so you get x equals 3. So basically what that means is x cannot equal 3, correct? That is where it's discontinuous. So discontinuous at 3. It's discontinuous at 3. So, but is 3 in the interval? No. So we don't need to worry about, the only discontinuity is there. So now we got to see if it's actually, if the derivative is continuous or if it's differentiable on the interval. So if it's differentiable on the interval, we have to derive this. So let's find the derivative. So you derive the top, which is 2x. Leave the bottom. Minus. Derive the top. Leave the top. Derive the bottom. All over bottom squared. Now for critical numbers, you set the top and bottom equal to 0. Do I need to set the bottom equal to 0 again? No, didn't I do that right here? And we found out that's not even continuous, not even part of the answer, so we don't have to worry about that's not going to be a max or min either because it's not even a point. So we set the top equal to 0. Let's first distribute the top, so if you kind of, it looks like, won't this negative and negative cancel? Make that a plus? So it looks like to me, looks like we have 6x minus 2x squared plus x squared minus 9 over 3 minus x squared. So when you combine all this, you get negative 1x squared plus 6x minus 9 and again, could I rewrite this as pull a negative 1 out and make this x squared minus 6x plus 9? Is that okay? And this would be 3 minus x squared. Now, do you see what's happening here? I just realized something. Would it have been easier to factor the top, cancel at the bottom, make it a lot easier problem to start with? Because look what we're getting at. It's a little bit more difficult to mess with. It would have been easier to right off the bat just factor the top, make it x minus 3, x plus 3. The bottom, pull out a negative 1. And then couldn't I just cancel these? And my new equation is now f of x equals negative x minus 3. That's a lot easier. It's a straight line with a hole. Isn't that pretty sad? I should have just done that. Anywho, since I've gone this far, this would have been a lot easier. Again, it's a straight line with a hole, which means, yeah, it's kind of mean value. It's going to be the same because if it's a straight line, it doesn't really, it's kind of weird. The whole thing's going to have that same slope as the line. So if I set the top equal to 0, actually no, I don't do that. Looking at this, the question is basically, I did all this work, looking at this, let's start over. Is this differentiable? Are there any issues that mess it up on the interval? No. So this one is differentiable. differentiable, we're okay. So it's continuous, but it's discontinuous, not on the interval. It's differentiable, except that x cannot equal 3, but we already took care of that. So we're good. So now we're doing mean value, or rolls, but you got to plug in the two endpoints. I've kind of jacked this problem up pretty good. Not jacked it, I've got a lot harder route, so hopefully you don't do the same thing on a test. Negative 4 squared minus 9 over 3 minus negative 4. What's that give you? Well, it's 16 minus 9 would be 7 over 7, which is 1. Is that okay? So negative 4, 1. And then if I plug it into the other one, f of 0 is equal to 0 squared minus 9 over 3 minus 0. That gives us negative 3. So 0, negative 3, and negative 4, 1. Can you find the slope through that line? So to find the slope through this line, you find the slope, which is going to be 1 minus negative 3 over negative 4 minus 0, which is 4 over negative 4, which is 1. I'm running out of space rather rapidly because I went the long way. Aren't I going to set the derivative equal to 1 now and solve it? I'm going to set the derivative, which I did all the simplification for no reason, really. But look how ugly this is. When I set this equal to 1, do you picture this is going to be a big pain in the rear to solve? But if I go up to the top, when I derive that, what do you get? Don't you get, when you derive the beginning, don't you basically get that the derivative is going to be negative 1? Did I mess up somewhere? Shouldn't this be negative 1 here? So when will the derivative of negative 1 equal negative 1? Isn't it always? So this is kind of a screwed up problem. So where does it have a slope that matches the secant? All real numbers. Now, you could try to set your derivative equal to negative 1 and try solving that. Which actually works because you could factor the top, cancel, and then you can make a proportion and so forth and try to solve it. But it would be way easier just to derive it from the beginning and deal with it. But this one is all real numbers because you have a secant line, and to make a parallel line to a secant line is the line itself.